This is a question which I had posted earlier on this page. Account for the fact that 4-cyanoaniline is slightly more basic than 4-nitroaniline and 3,4,5-trinitroaniline is more basic than 4-cyanoaniline. Let us look at the molecular structure of these two compounds, 4-cyanoaniline and 4-nitroaniline. Here you can see the structure of 4-cyanoaniline and 4-nitroaniline. Now we have to give a reason why this molecule here is more basic than this molecule. Now we know that there are certain groups which shows properties, and these properties are electron withdrawing properties and electron donating properties. With these two effects arises two electronic effects, and these are mesomeric effect and the inductive effect. Mesomeric effect can be either plus or minus, and inductive effect can either be plus or minus. Here in 4-nitroaniline, you can see that the nitro group here is one of the good electron withdrawing group as it shows minus M effect. And minus M effect is usually shown by those group which has doubly bonded oxygen or nitrogen. Here we can see oxygen being more electronegative and also doubly bonded. It becomes a good minus M effect. Is that it pulls the electron density from the carbon attached next to it and also from the rest of the structure to which it is attached. Though here cyanide is also a minus M group, that means it pulls the electron density of this ring towards itself, but it is a weak electron withdrawing group than the nitro group. Now, why is cyanide a weak electron withdrawing group whereas nitro a strong electron withdrawing group? Here in nitro group you can see it has two oxygens, which is one of the electronegative element, and also nitrogen here is one electronegative element which is higher than the carbon which it is attached to. So it has a greater tendency to pull all the electron density from this ring towards itself. Whereas here in cyanide group you can see there is only one nitrogen attached, which is more electronegative than this carbon, and no other electronegative element is attached to it. So as a result, the electron density in this ring decreases much greater than in this ring. As a result, what happens is that the acidity of the nitroaniline increases. If nitroaniline is having a greater acidity, that means the basicity here is very less and it is lesser than this compound. So what is the reason for greater basicity of this cyanoaniline is because of the weak electron withdrawing property of cyanide and strong electron withdrawing property of nitro. Because it has a stronger electron withdrawing property, it makes this compound acidic, highly acidic. That means it will be less basic. So if it is less basic, then this will be slightly more basic than the nitroaniline. Now, in the second part of the question, you are asked 3,4,5 trinitroaniline is more basic than 4-cyanoaniline. Right now, we saw that here 4-nitroaniline is less basic, whereas here you are asked why is trinitroaniline is more basic. This is the structure of 1, 2, 3, 4, 5 and 6. 3, 4, 5 trinitroaniline. Now, if you look at the ball and the stick model, here this is the nitro group, this is the nitro, and this is the other nitro group. From this ball and the stick model, you can see that this nitro group is on the plane and this nitro group is on the plane. Whereas the third nitro group here, you can see it is out of the plane. That means the oxygen, which is denoted by this red ball, one oxygen is above the plane and the other oxygen is below the plane. That means, do you see any space? If you try to place this nitro group in a planar position, you'll see there is no space for this nitro group. So what happens? It goes out of the plane. That means it is not in a planar position. If you try to look at the 3D model, you will see that this is the nitro group and this is the other nitro group. These two nitro groups are on the same plane and the third nitro group is out of the plane. Normally, we imagine this kind of a structure where the three nitro groups are in the plane with this amine group, whereas the actual structure is this one, where this is the amine group and this is the nitro groups here, which is out of plane with the benzene ring. With the same benzene ring with the amine group and this nitrogen are on the same plane, whereas these two nitrogens are out of the plane. This happens because of steric hindrance. Because of the sterically hindered position here, what happened? There is no coplanarity here. As a result, it is having a hindered resonance. The resonance of the lone pairs that are present on the nitrogen are no longer used up for resonance as there is no planarity. And due to this, the nitrogen lone pairs are now free for donation and they prove to be more basic. Here, the two nitro groups are sterically hindered, because of which it lacks coplanarity. And because they are not in plane, resonance or the minus M effect also does not happen. That means this nitro group is not as electron withdrawing now as it would have been if it was in the planar position. Now the lone pairs of the amine group is free for donation, and it can easily donate this lone pair of electrons and becomes basic. The lone pairs of the amine groups on this 4-nitroaniline is not available, as because it is on the plane. Okay, the nitro group is on the plane and it is pulling the electrons or the lone pairs of electrons towards itself. But here, because there is no planarity, now the electron withdrawing property of the nitro group decreases and these lone pairs are now free for donation and hence more basic. Now let us compare the three molecules. We saw that the cyanoaniline is more basic than nitroaniline. Why? Because of the less electron withdrawing property of cyanide than the nitro group here. But if this is less basic, how can this be more basic? Here we have 3 nitrogen. Here we have only 1 nitro group, but here we have 3 nitro groups. Even after having 3 nitro groups, we are having more basicity here and less basicity here. Why? Because of the hindered resonance here, because the position of the nitro group here is not in the planar position. Now there is no resonance that can be seen from this amine group. The lone pairs are now free for donation and hence it becomes more basic than this group.